Hello everyone, welcome to my talk. I hope you are doing okay in these crazy times we're living in the world. But today it's about tech stuff, so let's get to it. My name is Wilker. I'm currently working at Rome Research, and you may know me from some projects that I have on the Clojure community. And this talk is about me trying to give you some advice on some learned tips and tricks that I have incorporated to my own experience during 7 years that I've been coding on Clojure. So the first thing is I like to enlist a couple of things that I recommend that you don't do. And to start there, we're going to start with something that I call app-level default configurations. And this case comes from a real case that happened in Fulcro a couple months ago. That Fulcro, for those who don't know, is a client-side library that wraps React. So it allows you to use React with Clojure script and add some other stuff, but it's out of the context of this talk. What matters here is that Fulcro is been there for a while, and React has been changing as well. In the past, we used to define React components as classes. If you need some kind of lifecycle event to happen, you create classes. But recently, React is moving to a direction in which it uses hooks. So the components are just functions and they have stuff inside. What matters for our situation is that because Fulcro was born on the class level, that was what the component macro generated, the FSC macro generated. And if you want it to generate a function instead, then you have to add this configuration called use hooks to true, and then it's going to use that. But after using this for a while, you're like, yeah, I want to use the hooks all the time. So we had an idea like, oh, let's just make a configuration so the user can define if the default for his application is hooks or it's classes. And we could do that using something from Clojure script that's actually from Google Clojure, that you can set environment variables that will change on your application. And by doing that, when we flip that configuration setting that was implemented, then you could create a class component making using hooks false, and the default would be the hooks. Great, right? So why it's bad? What's the problem here? Okay, let's look closely. Imagine you created an app which has the setting for use hooks as default to true. And then you go by and write a bunch of dozens of components in your app. And then later in the game, you decided that you found a new UI library that you want to use in your code. But imagine that this library was created without even knowing about that configuration that Fulcro has. So it was assuming that a FSC would just create a class. But then when we try to integrate that, it's all broken because that would generate a function. Functions don't work with lifecycle methods. And in fact, what this configuration did was created a split world where in one side, people can use hooks and the other side, the default classes, and those can't mix. So this is quite bad. So what you can do in a situation like this? Well, wrap the thing. If you want to use the defsc macro, we can create our own defsc macro that wraps the defsc macro and does whatever we want. In this case, in this example, we are always adding the use hooks to true, merging on the config so the user can still override and they can still use it. And this is nice because this will only affect your own app, will not affect any third party. And even better, it gives you more control around how this function is called. So if that function has some changes in the future, you can accommodate as you please. And I think this is a general good recommendation anytime you are building some medium to large size apps and you are using a library and you're using some function extensively from a library. Like the FSC is used to define components. So if you're creating a Fulcro app, you're going to tend to use this a lot. And if you're using any library like that, I think is a good recommendation for you to wrap in your own version so you have more control over it. And just remembering, that's the benefits of wrapping. The second one, very important one, don't break things. And I guess Rich Hickey was the one that proposed most of that shake the world with the Spec-ulation talk. If you didn't watch, I highly recommend it. Alex Miller have been talking about some of that in the dependency heaven talk as well. Highly recommended. And just to summarize, they talk about we should not talk about changes, because changes, we need to divide changes in two specific types. Changes are growth or they are breakages. And they are growth when they are being an accretion, a relaxation, or a fixation. That means adding stuff, requiring less stuff, or fixing stuff. And breakage is when we require more stuff or we provide less stuff. In practical, to get it to more practical terms, let's look at some few examples. So for accretion, creating a new function is an accretion. So that never breaks anything, just add more functions. If you add a new arity to a function, that's also an accretion. It's not going to break anyone. You can do it as much as you please. Or creating new namespaces, same thing. On the opposite of that, providing less is a breakage and should be avoided. You should not do it really. There is delete functions or rename functions or delete namespaces or return less information. And I like to clarify that one a bit more. Imagine you have this situation that you have a function that returns foo and bar, but bar is expensive, and you realize a lot of the places you don't need bar, you just need foo. And one option would be to change my function and not return bar and just, I don't know, do it through some other channel. But by doing that, you break the expectations that the callers have on my FN. So this is why it's really bad. A thing that you can do to avoid this problem is just create a new function that does the simpler stuff and keep the old function using this new function. This way you don't break the interface and you can change all the colors that only need foo to the myFN asterisk, and nothing will break and it will work. Relaxation is when you require, for example, let's say you have a config map that you're requiring some stuff, and you figure out that, oh, I don't need bar anymore. I can handle my things without bar. And that's a relaxation, and that's great. By the way, if you're intrigued by that syntax for defining line specs is, there are two libraries on the Clojure community that implement that today, Guardrails and Ghostwheel. I highly recommend those, and I'm going to be using syntax a little bit more over this talk, so this is where it's from. Also, require more is really bad, because if I used to call your function and it works with just foo, and now you're saying you also require bar, then it's going to break stuff, and not happy. Also, add a new arity, add a new required argument. That's different from adding a new arity that we talked before, because in this case, I'm requiring that one. It's not an optional one, and that's a breakage. And we have listened about this pattern. They're like, okay, just if you don't know the name of a new function, just add a number to it. You have foo, now make foo2, or just make a new namespace. And I feel like a lot of people kind of have weird feelings when we suggest things like that. So you actually try it, and I want to show you how that works. Like in Pathom, on my library Pathom that I maintain, there is this concept of a reader, and that's an algorithmic implementation on how to figure out paths. And Pathom has been around for about 3 to 4 years, and in this time, this implementation had to change. But instead of just changing it, I created the reader 2 and then the reader 3, because their implementations were different enough that it could break a user if I just change it. And by giving new functions, instead of trying to force my users to use the new and shiny thing, if the old thing is working for them, just keep using the old one. Once they are ready to migrate, they can migrate on their own pace. You don't have to force people into migrations for things that are probably working for them. And I also had the same case with the namespaces, because I had this GraphQL namespace, but I had a bad design decision when I did that about how to convert names. I was doing automatic conversion between kebab case to camel case. And it ends up that this is a bad thing to do, because there is no rule in GraphQL saying that there need to be camel cases. So the result of that is that some GraphQL APIs could not be reached because of our naming conversion. So I add GraphQL 2 that doesn't did that. And then you go on the old one and deprecate it and just make it, let the users know that it's better to use the new stuff. And I'm no saint, have been broken things too. These are some of the list of the breaking changes I had on Pathom. I'm not proud of them, but they happen and I kind of regret it, it's bad. But luckily by me, that was very recent additions to the library. I think nobody else was really using that, so it wasn't that bad, but I would not do that again. I try to keep consistent about not breaking the things, because this is what can guarantee your sustainable software. This is what can guarantee that you're gonna update a library and it's gonna break under your fall, under you. And especially because maybe you don't even use in the library, just a dependency of a dependency, and that's some old stuff. And just keep the things there so things will keep working. And like Rich Hickey said, breaking changes are broken. And by avoiding breakage, you can let old and new coexist. And this is a pretty cool property, and I have a real situation that I'd like to talk to you about. There was the Fulcral and Workspaces situation. There is because Workspaces is this development environment for Clojure script that runs in the browser. And when Workspaces was built, the most recent version of Fulcral was Fulcral 2. So it was built with that. But Fulcral 3 came and was a major change to everything. So major indeed that at this point, it's a forking point for libraries that you have to make a decision. Do you break a lot of stuff, or you just create new namespaces and make effectively like a new library? Although they have the same name, they are very different things. And let's think what would happen if Fulcral decided to go to the path that it just breaks everything. And then I upgraded Fulcral in Workspaces. And remember, Workspaces can deal with other frameworks. Like our Workspaces in Fulcral 2 can deal with reagent cards or pure React cards or Angular cards, whatever you want, doesn't care. So it's about the structure of it. And inside, we can run cards. So technically, it should be possible to run Fulcral 3 cards. But if Fulcral 3 was just a breaking change, then Workspaces itself would not work. But gladly, Fulcral 3 was a new library, and because of that, Fulcral 2 and Fulcral 3 can coexist, and that means you can still keep using Workspaces and add Fulcral 3 cards. And that's a very nice property to have. So for the next point, let's talk about do not write macros. Macros are complicated, and they are contagious, and you should not write them. But I know you're gonna write them anyway because they are cool and sometimes they are nice. So I'm gonna give you a few tips around doing that. The first is around something that I call syntax macros. Those are like kinds of macros that you write because you wanna add some syntax or remove some boilerplate. And usually tends to because you're calling all other macros or special operators that you can't handle on functions. So it happens. So my first tip is use a lot of specs for parsing and validation of your macro syntax. What I mean by that is that let's imagine the defend syntax, or at least one version of it. You can get, first it expects to have a symbol, and then second, it maybe get a docstring. Then after the maybe docstring, you're gonna have the list of arguments, and after that, you're gonna have 0 or n number of items in the body. If you were to implement that syntax manually in some sort. And let's only cover this case that we may or may not have a docstring. What I have seen a lot of code in the wild doing stuff like this. So you check, if the first is a string, then it means that this is a docstring, and that means the second one is the arguments. And even on this simple case, this code is horrendous. It's terrible to read that. What you can do instead is write a spec that's like a regex spec. Spec supports this thing. There's like, if you think about regex on strings, spec has regex on lists. So you can say like the first element needs to be this and the other element needs to be that. And as you can see there in the docstring, you can say the docstring may be here and body is any number of things. And once we have that, instead of a macro, you can use the sconform from spec and use that spec to convert that syntax, that ordered list, in a named list, in a map. So you have direct access to the specific points without having to deal with all the parsing madness. Also, you can even reuse this spec to validate the functions. And this helps you in a couple of ways. First, it's going to tell your users they are calling the macro wrong. And by the way, if you don't know that, when you fdef macros, they're always validated. Since they run at the compilation time, Clojure will always run them. Also, another benefit is that because you're validating before it calls a function, you don't have to check on the macro if the arguments are valid, because sconform will always be valid since it validated it before entering the function. And also, when the error happens, spec can tell details about why it broke. So now that we know that, let's go back to example of Fulcro when we talk about wrapping the macro. Because back then we saw this reform thing that I didn't explain back then, but this is basically a way, a helper function that I created that gets the syntax, converts to a map, then applies a function to that map, and then converts the map in the syntax again. And this is quite useful when you are dealing with extending macros that are already doing that. So also, be sure to leave the macro, the arguments definition at a separated spec so people can reuse that when they are extending your macro for any reason. And Clojure has some standard syntax, so wherever possible, try to mimic them. So for example, spec def or def tests, they are pretty much like defs. Like def n, you're gonna have the Fulcro component definition or Pathom def resolver or guardrails def n. For let has a bunch of things that look like let. Okay? And what I mean by just reuse the syntax when it's close to it, I'll give you an example. Let's create a defn-like macro. And I made it two versions of it, on the left and on the right. One is correct, the other one is bad. Can you tell which is which? And yes, the left side is bad because that one is not a valid defn syntax, because the position of the map right after the symbol is not a valid defn. After the symbol, it must be the arguments list. While the other one, by just putting the map after the arguments list, made that map part of the body, and the body can be anything on defn. This means that validators and linters you can configure linters to tell that your macro looks like a defn, and they will understand it. While if you do the left side, it's very hard to get it working properly. So when writing syntax macros, be sure to use specs to validate and conform the macro inputs, and reuse standard syntax as much as possible. The next thing I'd like to talk to you about is about optimization macros. And that's a concept that I took a lot of time to learn and understand. And that's why I want to bring to you, because I think it's interesting and you might have usages in your project. And to demonstrate this, I'm going to talk about the Fulcro DOM helpers. And Fulcro DOM helpers are these functions that generate React elements. So in the basic of stuff, what you have to do is you want that function to generate that React create element. But one thing that has to happen during this process is that React create elements will always expect JSON objects. But since in Clojure we are dealing with the immutable maps, this conversion has to happen. And because doing elements, you can have pages with thousands and thousands of them. Although this conversion is relatively cheap, it can add up when you have a lot of elements. And that's where a macro can help. Because if we make a macro version of the do input, and we don't have anything that needs runtime dynamics on the value, we can convert that at compilation time at the macro and save us some runtime performance. Let's see how that would work. First, we have the initial Clojure script version of the input. That's the basic version that just converts at runtime and it works. And to make the optimization, let's create the same input but as a macro on the Clojure side. And that's another interesting thing. You can have a symbol, a namespace plus symbol that's both a macro and a function. And when you do that, first you have to require the macros on your namespace. And now when you call the input like that, it's going to use the macro version because it can call it as a macro. And if you look at the macro, I put just some small boilerplate just to have an idea how this conversion can happen. Of course, this is not a complete thing. There is a lot of mistakes needs to be fixed in this code, but when it demonstrates that if you call the input, it's going to call the macro. But if you do apply, like get the input as a reference, because you can't use macro as reference, Clojure is going to use the function version. And the same if you want to pass this as an argument on anyway. So this is a super cool trick you can use, but use with care and do it later, only when you see that you can gain performance. Please never start by doing that because macros are more complicated and there are bugs that can arise for doing this. So be diligent on the usage of that. Now I want to talk to you something about building for extension. That's the second part of my presentation, and we're going to talk about building stuff that lasts and that's easy to evolve and change. The first tip on that is use qualified keywords. And qualified keywords are keywords that have a namespace. And it's super important, but why bother? Like you have to write more when you do that. So why bother? And the first argument I get to you is that namespaces are information. And to exemplify that, look at this map. What this map tells us? Well, the auth token probably authenticates something, the name of something, and something will time out after 3000 milliseconds. That's some information, sure, but let's compare it to this. And now, because the namespaces can add the context and say, okay, auth token, but auth token about what? And auth token, in this case, about a YouTube API. And the name about what? The Electro app. And just by having that, you add a very robust layer of information in your properties. And if you just navigate these kinds of properties around, it's much easier to understand what your system is doing and what each property is for. Imagine if Clojure didn't have namespaces. Imagine if all our functions need to be in this flat scenario, like C is, or the other, yeah. That would be a really mess, right? Because then you have to be like, oh, maybe that name is used. And when you create a namespace, then you're like, okay, I have this namespace that's mine. I can use my organization name of it. And now I can use these short names that I know they're not colliding to anyone. And you should namespace your keywords in the same way you namespace your functions for the same reason. It enables you to track it down and understand where it comes from, what it's doing, and what's the context, how I should be using that. And that brings me to something I like to point out. There's a very different thing about the value types and semantic types. And let's think of that in the context of HTTP headers. If I create a spec for headers that says that it's a map, that keys are strings and values are strings as well. This definition, the map of it's the value type of it. We are specifying, this is the data type that's going to hold this information. But it's not the semantic type. There is like, I can have a lot of maps that are strings there for many different reasons. But in this case, we're saying that the key headers, these qualified key headers, use that type, and we are also creating a semantic type. And we're defining this as something context. And we can later define even more sub-semantic types of it. For example, you can understand the concept of a header, but there's also request headers and response headers. And although all of them are the same map type and even the same structure, they are used for different purposes. So giving them different names enable you to know right away when you look for that key on a map, you know, oh, okay, this was supposed to be used on the request. And you don't need anything else to do that. Just this piece of information is very informative by itself. And by the way, semantic types don't require spec at all. Semantic types are just about having this name that is consistent across your system. And that's the problem about unqualified keywords. Because their names are so short, the risk of something else in your program using that same name is very high. So you can't guarantee the uniform consistency of the name. And that's why qualified is important. So this way you can guarantee and you can get that semantic meaning flowing through your system. Another cool advantage of keywords qualified is that you can get very nice autocomplete. And I'm gonna keep running a GIF here that I recorded from a 2D library I was writing. And as you can see, because my editor can just look at all the keywords that I mentioned, when I'm trying to use that, it can really help me to remember what those keys is about. And I find this saves me so much time while development, when I have that, and frustrates me a lot when it's not available. And so to summarize, just add another column. If you are creating new keywords and you are not sure where to put or what namespace, just make it a fully qualified on local namespace by adding a second column to the definition. And now I want to talk to you about something that I call the end map pattern. And that's something I grow on me as I build on Clojure slower and slower. But I think it's such a powerful pattern. And first, let's understand the problem it tries to solve. And this is a real case from the Rome research project that I've been working. There is some old code there for interacting with Firebase. And at some point, we needed to do sharding. So the thing was, before sharding, we had no need for knowing what database URL Firebase was using. But with sharding, that turned out to be an important information. So we had to change that dbref function to also accept a URL. The problem is this function is in the middle of a lot of Firebase process. So this cascades a lot of changes, and I'm just showing you it partially. There's a lot of places that need to change just to accommodate this new extra optional argument. And that's how positional arguments make your system hard to extend, because anytime you figure out that you missed something, and that's going to happen a lot of times, there is never a way that you know everything that's going to happen. So it's very likely that you need to add stuff. And if you need to add this oppositional argument, you're going to be in this hell every time. So to solve that, maps are love. And I can show you what we are doing to refactor this library, the new version of our Firebase helpers. And they look more like this now. As you can see, a lot of them get this env parameter. That's why I call this env pattern. That is, I like to put a map when I'm in the middle of flowing processes. I like to have my first argument be a map that's an environment that will tell me like all the contextual information I need to know about it. Although that one is not as env, it's still a map and still the env thing. And then you can see how much simpler all the other functions get. Because now they don't need to care about so much about the environment. The environment is something that they flow around, but they don't need to know every detail about that. And that's illustrated, and I'll put some specs for you just out of curiosity if you want to see what they look like. But it's like, also when you use that and you're gonna have a lot of env arounds, when you are speccing those envs, you should use the S keys. And notice that in those cases that I'm highlighting right now, I just flow in the env. I'm not pulling anything. Like these functions, they don't care about anything specific on the map. That's why you just use S keys purely. And when you call S keys purely, it's gonna validate all namespace keys on the map anyway, even if you're not requiring them. So you can detect errors very early. But other cases that I highlight on the top left now, you can see that when I use the key on the map, then I talk about that on the S keys, because then you can make a required. This way you don't have to leak the requirement needs for each function to their parents or something like that. This enables locality, and I recommend that you use this a lot, because instead what people tend to do is like they try to create some definition of an entity, like oh, this is a user and the user is always going to have these keys. No, don't do that. Just in every function, specify the exact keys that that function needs. This way you get a very fine-grained control of specs and definitions, and that's why the namespace keywords in spec are so useful, because they allow you to easily do that. Another example of thing that does that already does that, something like that, is pedestal context. If you use pedestal, pedestal is a Clojure HTTP library, and pretty much what happens in these libraries, and ring is another example, is that they start creating a map with the request information, and then this map gets crossed to the interceptors that could like parse the body, parse the URL params, and do all the things. And what they do is they just keep adding stuff to that same map and change it. Up to a point, it's gonna call your controller, your handler for that endpoint, and then it's gonna fill up the response, and then in the end return another map. And this is what a very simplified version of what this map can look in the beginning and in the end. So this is a nice pattern. But I like to one thing I like to point out there, this is my personal opinion. I think flat structures are always simpler than nested structures. So I would prefer having request headers as one parameter instead of having request and headers inside of it. Because this way you can actually merge the information. It's more information. Because if you get just the map inside of request, just the headers, you don't know what's that about. But if you got with request headers as one keyword, you would know. And to me, in my opinion, this should even be bigger. So I know this is about pedestal. So if I read that and I understand what a pedestal request header is, I got it. I don't need to guess. I can guess myself like, oh, maybe this was written for a different library or something. So there is no guessing if you have the full names all the time. And it's everywhere. Ring does that, pedestal does that, Pathom does that with the end, Wilker does that. If you use the component library, it's kind of like that. You're creating dependencies that are just building up this map, and then you usually pass this map around as an environment. So this is a good and sustainable pattern that I highly recommend you to try out in your next project. And when I think about all of this, it reminds me about Rich Hickey talking about how software should be like a machine. And that's how I think about the env when I'm building that. This env is like every function is a machine that my env is passing through, that's building up and getting more information to the next machine, and so on and so forth. So against that, just like I want to say, let the env flow. Don't hold it, just flow it. Flow the information. It's going to make your life so much easier. And as a final thought, I like to suggest that you write every piece of code like you're writing a library. Sustainable and going. And that's what I have for today. Thank you very much for watching my talk. And we may be hiring soon in Rome. Keep on. Cheers.